Hello. Um, I guess we're doing this remotely today. Um, Today we're doing how can we determine whether a substance is pure? So that is today's title. How can we determine whether a substance is pure? That's probably yesterday's date. You're watching it a day later. So can you write down the title and then the starter? As you can see, there are 6 different compounds: CH4, Na2CO3, K2CrO4, this long one, FePO2, PO42, and CH2, 3Cl2. Lots of letters, lots of numbers. For each of those elements, can you write down how many elements there are of each element in that compound? So for each of those compounds, can you tell me how many of each element there are? For example, CH4, there is 1C and 4 H's. That's it. Simple. So write down the title, and then for the starter, write down CH4 and then say C, there is 1, H, there is 4. Then do the same for Na2CO3, and so forth, all the way through for all 6. I will do the answers in a moment, so probably a good time to pause the video and do the answers. So pause, or you or the teacher, somebody pause, and then we'll go through in a minute. I'll just wait. Okay, right, so the answers are as followed. Let's move on. Come on. Oh, it's being very slow. The first one, CH4, is, as I mentioned, it has just 1 C, so I've written 1 times C and 4 times H, 4 H's. Na2CO3 has 2 times Na, 2 sodiums. It's just got 1 C there, so 1 C and 3 oxygens, because there's an O and there's a 3 there. So 2 sodiums, 1 carbon and 3 oxygens. The next one, K2CrO4, we have 2 Ks, which is potassium, 2 potassiums, 1 chromium, 1 times Cr, there's just a Cr there, and 4 oxygens, O and a 4. Easy. The next one's a bit trickier because they're not all grouped together. The CH3, CH2, OCH2, CH3. If I cross off my C's, 1, 2, 3, 4, I have 4 carbons, so I've written 4C. Now the H's, I've got 3 there, plus 2 there, plus another 2 there, plus a 3 there, which makes 10. 10 times H. And last but by no means least, oxygens, there is 1 oxygen, so I've just written 1 times O. Easy. If you're not sure, if you haven't got that so far, you can just do the next 2. If you want to pause, do a bit more, or the answer will come in just a second. And this last one, it's a bit trickier because there's brackets. So Fe3 brackets PO4 2. The Fe and the 3 are next to each other. They're outside the brackets, so there are just 3 Fe's, 3 ions. Now, if we look inside the brackets, there's 1 P, 1 phosphorus, and 4 oxygens. 4 oxygens, easy. But there's a 2 on the outside, so that just means everything inside is times by 2. So whilst there was 1 P and 4 O, there is actually 2 P's and 8 O's, 2 phosphorus and 8 oxygen. So for this one, the answer is 3 ions and 2 phosphorus and 8 oxygen. And if we apply the same principle to the last one, CH2 and then 3 and the brackets outside, and Cl2. Inside the bracket we've got 1C, so I've written down 1C, and 2 H's, 2 hydrogens. But then there's a 3 outside the bracket, so everything in that bracket is times 3, so I have 3 carbons and 6 hydrogens. And here we've got a Cl with a 2, which means I've just got 2 chlorines. Okay, a lot of information. That's just a starter. Hope you got all those. Give yourself some green pen ticks, stamp, stuff. Okay, next bit. Okay, purity. What is meant by purity? When you talk about something being pure in everyday life, you're often not referring to its chemical purity. For example, you often hear orange juice or mineral water advertised as pure. But look at the label on the bottle of mineral water. Figure 1. Here it is. Woohoo! Here we have calcium, magnesium, potassium, sodium, bicarbonate, chloride, sulfate, nitrate, iron, aluminium, dry residue, pH. All of these are different ingredients in your water. In advertising a product as pure, it is taken to mean as has nothing added to it, and that it is in a natural state. For example, pure orange juice means from freshly squeezed orange. However, to a chemist, a pure substance is one that is made up of just one substance. That substance can be either an element or a compound. Don't worry, there is a note for you on the next slide. It's a blue box. It means, what does pure mean? In science, a pure substance consists of just one element or just one compound. Most substances are mixtures or impure substances which contain more than one element or compound. Blue box, pause the video, write it down. I'm just going to get this bit ready whilst you're waiting. So pause, and write it down. Okay, so in science, a pure substance consists of just one element or just one compound. Most substances are mixtures or impure substances which contain more than one element or compound. Now, many useful substances are mixtures. Mixtures are not bad. If things are pure, people try to make pure sound better. That is not true. Alloys, metals, are mixtures of metals with desirable properties. Brass and bronze, steel are examples of alloys. They're better than their normal or classical elements. Drinking water is a mixture of water and chlorine to kill bacteria and fluoride ions to keep your teeth strong. If they weren't in it, you would probably get diseases. And pure Tropicana orange juice is a mixture of many different chemicals found in oranges. Pure does not mean better. Pure just means one compound or one element. Okay, time to test to see whether you've paid any attention to what I've been saying or if you've even read what you have written down. There are 3 parts to this question. Can you, first of all, state what a chemist means by a pure substance? Then, can you, maybe in a table, name 3 solids, 3 liquids, and 3 gases which are pure substances? Hint, maybe use your periodic table to help you work that out. And for the last one, explain why pure air is a mixture and not a pure substance. So, state what chemists mean by a pure substance. Look back to what you've just written. Name 3 solids, 3 liquids, and 3 gases which are pure substances. Excuse me. Again, use your periodic table to help you. And then last one, explain why pure air is a mixture and not a pure substance. If you will pause the video now, and you can answer those questions. Probably give yourself about 10 minutes, because it's quite a lot of stuff. Just have a drink. Are you done? Okay, let's check your answers. Did you have any of these as answers? The pure substance is a single element or compound, not mixed with any other substance. Examples of solids that are pure: anything from the periodic table, like iron or sulfur, or any compound taken from things from the periodic table, sodium chloride, table salt. Liquid elements in the periodic table are something like mercury or bromine. You could also have water, pure water, or ethanol. Any gaseous element, oxygen, hydrogen, or carbon dioxide. The oxygen is a pure element, hydrogen is a pure element, carbon dioxide is a pure compound. Pure air is a mixture of nitrogen and oxygen with small amounts of carbon dioxide. So air couldn't be described as a pure substance, but it is made of different elements and compounds. Okay, how do we know when something is pure? Chemists can use a process where they heat it or cool it and condense, and basically you track how it melts or how it freezes, and from this you can tell whether something is pure or impure. Let's look at this graph. On the left hand side below the dotted line, what is the state of that substance? Shout your answer gently. Did you say solid? Congratulations, you win a prize. Below the melting point, it is solid. It is not melted, so it is not turned into a liquid. Above the line, what is it? Did you say liquid? Excellent, even if you only said it to yourself in your head. So we have solid, and then we have liquid. And between the two, it has melted. But look at the difference in the melting of those two substances. The brown line, it goes up, and it has a nice horizontal, completely horizontal line as it melts. The green line doesn't go horizontal at all. In fact, the green line is constantly changing, and that's how we can tell the difference between a pure substance and an impure substance. A pure substance will not change temperature when it's changing its state. A pure substance will melt at a fixed temperature, and at that temperature it will stay until it is melted. A pure substance will boil at a fixed temperature. It will not change temperature until it has changed state. An impure substance will change over a range of temperatures. It does change as it changes state, and that's how we know that a substance is impure. So here's a little note. Boop, boop, boop. The melting point is the temperature when a substance changes from the solid state to the liquid state. We can use the melting point to determine if a substance is pure or impure. The melting point of a pure substance is a single temperature and is different for different substances. For an impure substance, the melting point is lower than the pure substance, and the melting point may have a range of different temperatures from the different substances. So, maybe write that down. No, do. It's a blue box. For an impure substance, the melting point is lower than the pure substance, and the melting point may have a range of different temperatures. I'll pause whilst you write that down. You got that? Good. There wasn't many words there. Should be quite easy. Okay. How do I know? If I give you... I have water here. How do I know it's pure water? Well, I've drunk it, so hopefully it's not anything poisonous. But a chemist, someone like Mr. Meunier, how would he determine whether it was a pure substance? Well, things we know about water. Water, when it's solid, is ice. And when it's turned into a gas, it is steam. What temperature does it turn into ice at? Where does it go from liquid to solid? Is 0 degrees. And I can't do 100 with my hands. And what temperature does it go from boiling? It goes up to 100 degrees. So, if I wasn't sure whether this was pure water, I could stick it in a saucepan and start to boil it. And if it started boiling at 100 degrees and didn't go higher than 100 degrees, I know I have pure water. If it starts boiling before 100 degrees, it means it's not pure water. If I put it in the freezer, it's difficult to be in the freezer to test the temperature, but if I put it in the freezer and it starts to freeze not at 0, then I know I don't have pure water if it freezes at a different temperature. So here we have that nice horizontal line for when it's boiling at 100 degrees. It doesn't go above 100 degrees until it's all boiled away, and it won't go below 0 until it's all frozen water. Love it. These are just two pieces of equipment that you can use to measure the melting point of different apparatus. They look overly complicated, but the main thing is, if you want to measure something, you want to heat it, melt it, evaporate it, using a real Bunsen burner means it gets really hot really quickly, and it's really hard to see a nice, smooth graph like this. So what you do is you kind of heat it second-hand heat. So for example here, the thing we're testing is this stearic acid, and what you do is you don't heat that over the Bunsen burner because it will just heat too quickly and we won't get a proper set of results. So what you do is you place it in a beaker of water, and then you heat the water until the water's temperature increases, which increases the temperature of this stearic acid, and there's the thermometer in it, so you're kind of heating it by a second-hand heat, so it heats in a much gentler fashion. Here is another example. Here we've got a capillary tube with a substance being tested, non-specific substance, and this time what they've got is oil or water, but instead of heating it in a beaker like this, they've got it in a kind of funny, I don't even know what this is called, it's like a bee. They heat it, and if you apply the heat away from the substance, this liquid here gets hot, the heated substance moves up, it warms this thing here, and then the liquid can fall down, be heated again, and go round and around. So to measure the melting point of something, you don't heat it directly, you heat it indirectly by heating something that it is in. But you don't need to write that down, but it's good to see. Maybe. Last notes for today, then we'll do some questions. In summary, an impure substance, like the one shown in this graph here, we know it's impure because it melts over a range of temperature. This line here is not horizontal. This is where it is solid. This is where it's melting. And this is where it's liquid. That bit is not a horizontal line. When you're sketching that in your graph, make sure that is not horizontal. Whereas this one at the bottom, this is a pure substance because it melts at an exact temperature. See this horizontal line. Last notes, so pause the video, write that down, sketch the graphs, add the notes, pause, sketch, write, unpause when you're done. Good? Right, let us move on. Simple. First of all, there are 6 things on that little table. Can you just write the numbers 1 to 6 and tell me which ones are pure and which ones are impure? I will wait. 1. Oxygen melts 219. Is it pure? OJ melts -2 to -10. Is it pure? Gold 1063. Pure? Lead. Pure. Tin. Pure. Soldier. Solder, not soldier. Solder. Is it pure? Let's check your answers. Oxygen. 1 melting point. Must be pure. Orange juice. Range of melting points. Not pure. Gold. Pure. Lead. Also pure. Tin. Pure. And solder. Impure. Range. Ooh, when I said there was no more writing, I lied. But I forgot. The last thing. Sometimes, so things we've talked about, like some things are, like orange juice is not pure, it's a mixture. But we don't make that mixture. Oranges make them themselves. Nature makes oranges. And we just steal the juice from the oranges to drink for breakfast or other times. But sometimes we humans, particularly chemists, like to make things together and they are useful. For example, drugs, as in medicine. The medicine you receive from a doctor or a pharmacist has to be put together very, very, very precisely. If it's not put together precisely, it won't do what it's supposed to do, and it could kill you. And so, for it to be put together precisely, we have something called a formulation. A formulation is a mixture that has been designed to produce a useful product. In a formulation, every chemical has been added in a carefully measured amount. Each chemical has a specific purpose in the formulation. Here we go, for example, this is a drug. 5 to 10% is the drug. A few bits are colorants. There's a sweetener, so it doesn't taste disgusting. A smooth coating to help you swallow. And other bits that help you dissolve in your stomach, in your digestive system, to be good for you. So, the last thing is write down a formulation. We'll give you another minute, maybe pause, or not. Got it? Excuse me. Okay, here are just some examples of common formulations. In paint, if you buy paint, the pigment, the colour, is a formulation. The right amount of pigment gives you the right colour, the wrong amount will give you a different colour. They also have to add a special agent to help the paint stick to whatever it is you're painting, the wall or the door. And then sometimes they add a solvent, which means it's thinner, so it doesn't go all lumpy and it will spread nice and evenly all over surfaces. Other examples of formulations, things like washing up products. You'll have a special thing called a surfactant, which helps remove grease. It has water, because it means it's going to come out the bottle easier. They add colours and fragrances, so it smells nice, lemony or fresh, and not fresh. And a last part, which is a rinsing agent, which means when you finish washing your plates, it isn't still covered in washing up liquid. Time to do some questions. Do you know what? I'm not going to read these questions for you, because there's plenty. But the questions are here. I'll allow you to do them, and then the answers are on the next slide, and I'll allow you to read them. So I'm just going to leave that there for a minute or so. So pause, answer the questions, and then I'll put the answers up. And then after that, there'll be some more questions. Okay, going to move on to the answers. So if you don't want to do that, pause or whatever. Going to move on. Those are the answers. And after this, there are one more set of questions. for those of you who've just flown through. And last set of questions. There are no answers to this, so just pause this now and answer the questions. We can maybe answer them. Check your answers when I see you next time. Okay. Hope some learning occurred today. Okay. Love you. Bye.